Hello, guys. So, today we are gonna watch this video, complete backend software engineer mind map, everything you need to know in 2 hours. The next 2 hours, we have this, probably less than that because I'll go with 1.5, but probably more than that because I will make my commentary on it also, what I know from development.
Be aware of as
Let's
a backend engineer is going to be talked about in this video. I put together this insane mind map, which is going to talk about every major technology and show you where it fits in the bigger context. Now, if you want to become a backend engineer or strengthen your backend engineering skills, you don't have to know every single technology in this mind map. This is about helping you think and speak intelligently about different technologies and helping you understand how everything is connected. If you want to take this information and turn it into a step-by-step roadmap, I'm going to do that in a follow-up video, so stay tuned for that. And we're going to go through this. If you want to follow along, I have a link to this down below. This will help you get the most up-to-date version if I do end up adding or changing anything in this list. You can also print it if you want to use it as some kind of reference. So to start, we're going to go into the backend frameworks, and there are a bunch of different languages here. The main takeaway from this is that you can program a backend in pretty much any major programming language. Certain ones are going to be more popular for web development, and I would generally recommend to pick something that has a decent level of popularity because this will basically show that enough people have gone through it and issues have been resolved, and you're not working with some super cutting edge technology that doesn't have a lot of development over time or resources for support. And that's going to be something that you can apply for pretty much any technology. I generally like to recommend people get newer technology that's not super dated, but not so new that you're working in basically a beta software where you have
I only recommend new technologies to people that already have experience. Let's say you know 2 or 3 languages, then learning something which is a very new language does make sense. But if you are a person who is just starting up, it does not make sense to just start with, let's say, Rust. It does not make sense to start with Rust. You should go with proper C, C++, or Java, or Python as well, or JavaScript, but not Rust or Go. Go is okay, but your concepts would be much stronger if you go with a much older language, and then you can build up on that, and then you can skip a lot of languages in between, and then you can come to newer languages like Rust or Go, or like newer heavy languages. Though JavaScript is also heavy, but if you are following, I have a text. Cool.
to worry about breaking changes or running into issues that nobody else has faced before. So we'll go through each one of these, but it's important to understand that you first have the programming language. So for example, we have Python, and within Python, you will also pick a framework. So a framework is basically just a more extensive library that someone or some team created to help you build applications. That way you don't have to build everything completely from scratch. So in the example of Python, 3 popular ones are Django, Flask, and Fast API. There's probably like a million others. Choosing a framework, it's often the case you'll so if you're given an application written in Django, then yeah, use Django. But if you're starting with a brand new project, you can think of the targeting of that particular framework. Often it's the case a framework will target simple, small applications or building large enterprise applications. And it makes sense to pick the one based off of what you're trying to build. So in this case, Flask will give you a really simple start. You can get an application going in a single Python file, whereas Django is going to give you a little bit more structure and the setup is more complex, but it might be the framework for you if you eventually are going to have a more complex backend. Then it's probably the case there will exist frameworks that will target a particular feature or capability. So with Fast API, it's all about creating very performant APIs. So that might be something for you as well. And if you're watching this thinking, wow, there's so much stuff here, where do I even start? It's often the case that you can achieve the results you want with many different languages or frameworks. You don't have to choose exactly the right one. So I recommend following some learning path and sticking to that so you can become familiar with all of these different technology categories. So at the bottom of the roadmap, I have an example learning roadmap, and you can follow through with that, or you can wait for my upcoming video, which will go through that material. Now, if you need a little bit more support, I do offer one-on-one mentorship, and this is if you want me to meet you where you are in terms of skill, but let's get back to working on the backend frameworks. Let's just go through each one of these in no particular order, but I'll grab some of the more popular ones first. So we have JavaScript. There are a lot of different options here. One of the biggest ones is Express.js. This will give you a really easy way of building a backend API. Next up, we have Nest.js, which is going to achieve similar results, but it gives you that larger framework. So you could kind of compare this to Python's Django and Flask. Express.js gives you this.
So next JS feels like an object-oriented library or framework, but Express is more like JavaScript, where you write line by line code and execute that. But next feels like more object oriented, though it's not. But yeah.
simplicity, ease of starting, like you would get with Flask. And then Nest.js is going to give you everything you would possibly need, kind of like Django. And when you have larger systems like that, it often comes with different conventions or
Yeah, so let's say if I want to compare Nest versus Express, I would say that Nest would give you less flexibility, while Express would give you more flexibility to do things uh, and structure your code in a way, while Nest would not give you that.
opinionated approaches to developing software. For some people, that
Yeah, opinionation, like Nest has more opinionation built into it. Like the developers of Nest thought some things should be written in some way, and they did done. Express is not that opinionated, but obviously you can it has much more opinions than uh, the standard node.
that's great. It gives you exactly how to do things. But for others, you might want a little bit more freedom and not to have to kind of fit into a strict system. So in that case, you might want to go with something like Express instead of Nest.js. Then we have Fastify, which boasts faster speeds and a better development experience. That's ultimately going to be up to your judgment, but that's because these are often used to create full stack applications and they just have a backend component to it. So these are kind of different technologies than Express, Next.js, and Fastify, but I wanted to put them in here because they're going to give you guys React components and it's going to give you the framework for building operation. Overall, it's a really cool technology within JavaScript and you're already using React, then it would just make sense to check out Next.
Yeah, so if you're already using React and you want to make a full stack application, why just not use Next.js, which is a full stack framework for React? So I see Next.js as a backend framework where it's templating library instead of like EJS or something else. It is the templating library is React.
Next.js and see if it's right for you. Nuxt.js is very similar, but it's utilizing the Vue JavaScript framework. So Vue is similar to React, a front-end framework with this, ASP.NET Core. You may also hear ASP.NET MVC. This is a great option, but it's within C Sharp, which is largely tied to the Microsoft environment. So in this context, there's a good chance you'll be working with Microsoft SQL Server, Microsoft Azure. If you're in a Microsoft shop, then yeah, it makes sense to use C Sharp. Otherwise, there's a lot of other options on here that aren't coupled to a particular system. Now, that doesn't mean if you use C Sharp, you have to use Windows or you have to use SQL Server or any of these other Microsoft products, but it's developed by Microsoft, so that's where you might get in Spring Boot. Java
So generally you have to. It's you if you are building products for Microsoft, it's much preferable to use C Sharp and .NET framework work. But though C Sharp .NET framework could be used for multiple things, it could become a REST API, it could become Mac OS applications, Linux application. But generally, when you are making Windows application, you use C Sharp.
experience. I've used C Sharp for various things, and overall, it's really great. You'll probably get a very similar experience with Java and Spring Boot, Java being the main programming language in the Oracle ecosystem. Now, if you're going
So, this is the story behind C Sharp and Go. So, when Oracle bought Java, they from those Sun Microsystems, they started uh, like they wanted Java to be so Java was the most one of the most widely used enterprise language, but they wanted to license Java and they wanted to collect money from that. That case went in court and Oracle lost finally, but till that point, Microsoft decided that they want to build their own language and not be dependent on Java. And Google decided that they also wanted to do the same. So Microsoft built C Sharp and Google built Go.
for Spring Boot within Java, there's also Kotlin, which is often positioned as a potential replacement for Java. And Kotlin also has a Spring Boot framework, as well as this KTOR framework. I'm actually not sure how to pronounce that, so I don't want to assume. I haven't personally worked with that, but it's probably a good option if you're working within Kotlin.
Okay, so what is the difference between Kotlin versus Java? Null safety, conciseness, extension. Hmm. Okay, it's interoperable with Java. Kotlin has better performance. Okay. Cool. Makes sense.
PHP is very huge for the web. It powers things like WordPress. You can use it for custom backend.
I hate PHP. And if WordPress didn't use PHP, PHP would have been dead. And that's my uh, theory. But it does use PHP, and now we have to uh, like have PHP everywhere. Uh, PHP is just too much to learn.
With CodeIgniter or Laravel. I haven't personally used PHP in this context, but I know it's very popular. It wouldn't be my personal first choice, but there's not anything necessarily wrong with it.
Yeah, there are also a lot of security flaws that come up with PHP that you have to manage, which don't come with building a REST application.
I would just probably choose JavaScript or Python, or I've actually worked with Rust professionally, and I use the Axum framework. So the interesting about Rust, while it is newer and might not have the established history that you might get with some of these other options, it is a really good ecosystem and gives you the power of a programming language like C++, but has a better ecosystem for things like API development. So you wouldn't typically build an API with something like C++, but with Rust, you can easily do that. Actix is another popular one, but within every language, there's like 100 frameworks. So I'm just putting a few of the most important ones. So I had a pretty good experience developing in Rust. Definitely did have that feeling of like, wow, this is newer, not nearly enough support or people who've solved this particular issue yet. But if you're already working within a Rust environment, maybe you're using Rust for some lower level programming and you want to build an API, then this is awesome. So I definitely see Rust being a much more popular option going forward, web apps and microservices. So Go is a great option if you're already in that kind of environment. Here are two frameworks with Go. Next up, let's talk about
Gin and Echo. Mm. There's also Go Fiber. Go Fiber, which is good. Gin, there's Echo. I right now prefer the standard library is very good for Go. So I think if you look at the standard library and try to make your own system with Go, because the standard library is so good uh, for API development, I think that's a very good option.
about Elixir, we have Phoenix, and then Ruby, we have Ruby on Rails. All of these would be great options. It just depends on which language you end up going with. Elixir is a functional programming language. The people that use Elixir seem to love it. It's not super popular, and also probably wouldn't be my first choice as a language to use for building a backend. I did use it for one particular job and used. While a lot of the principles of how to design the app were the same, I just felt the learning curve to go to a functional language like Elixir was a little bit high. Up having to work on it. Not nearly as many people work with languages like Elixir, Rust, Kotlin, and Swift, which I really wouldn't recommend for a backend language. I think it's too tightly coupled to the Apple ecosystem. You may use Swift for building the actual iPhone application, but when it comes to the backend, I probably wouldn't choose Swift unless I knew it was only going to be used in that specific iPhone app. I would not choose Swift and using Swift, but Kotlin is often used for Android app development. So you might end up using Kotlin for the Android app, but then choose a different language for the backend. If you're already developing in Kotlin, then you could potentially create some stuff in Kotlin for the backend. But if you were just trying to create a general backend and you needed to choose one of these programming languages, I probably would choose something that more people have used, such as JavaScript or Python. I generally do concern myself about the popularity of the language and the framework. It's not the only thing I use to make a decision on which one of these to use, but it definitely is a factor. A great way
Popularity should be a factor because when you are hiring devs, when you are bringing devs to your team, and if you're working with a super niche technology at this age, you'll always have a disadvantage with the amount you are spending to keep developers, the amount you are spending to hire people, the amount you're spending, but to like maintain your workforce, and that is a problem. But the added advantage, if you have the money, the added advantage is that people with a high level of uh, creativity, a high level of stride to learn things, go with much more niche subjects or topics. So people that generally are very interest driven rather than money driven or like which or like any other alternative motive driven. So in that case, that is a good way to filter those people out. So these languages filter those people out. But if you go with these languages, it's easier to find developers. If you go with these languages, which are very less used, then the problems increase. So I think these are the best place to be at.
Way to get an idea on popularity is using surveys such as the Stack Overflow survey, basically JavaScript, Java, C Sharp, very much support, which are the major programming languages. There's probably web development frameworks for a lot of these other languages, how other languages and frameworks fit into this larger model. Is like, here looks great. WebAssembly is a technology basically allowing you to use any of the major backend programming languages to do certain things on the front end. So if you're familiar with web development, you probably know that JavaScript is the main programming language for front end development. So if it comes to just learning as little languages as possible, you can pick JavaScript because you can do the front end and the back end, and you don't have to learn a different programming language for the back end. However, this could be changing with the adoption of WebAssembly, as it is allowing us to use other programming languages for things on the front end. I think this should have a capital W here, but everything has different uppercases and lowercases. But WebAssembly is a target. So if you imagine taking a compiled language such as Rust, and instead of compiling that to run on an x86 machine, you could compile it to run on WebAssembly, which is supported in a browser. So the browser is acting as an interpreter for WebAssembly, allowing us to use these other languages for front-end work. So it's likely the case you're still going to have JavaScript. It's more so that for certain things, you could use these back-end languages for front-end things, especially if it's very performance heavy. If you're trying to make a video editor or a maps application or something that requires a lot of computation and you want to run that within a browser, WebAssembly might come up to make that more performant. It's not a different language, it's just a technology that'll utilize these languages you're already familiar with. It's just going to help you have more functionality from these languages. This does kind of get into the front end, but this is likely something you'll want to be aware of as a back-end engineer. Next up on this list, I have ORMs and database libraries. Now, I didn't go through every ORM and library that exists. There's just unlimited. For every major programming language, there's going to be libraries for working with databases. Now, these could be libraries to work with one particular database of some of the most popular ones here. Now, I listed out ORMs, and I'll explain what that means here in a second, but you may also find libraries to work with a particular database. So if you were working with Postgres in a certain language, there might be a library to do that for you to make that connection easier. The first four on this list are examples of ORMs, which we'll talk about here in a moment, with Rust, and this is a database library that will allow you to execute. So this is an example that in a moment. Then we have a database library, SQLX. Let's talk about this one first. So this is an example that I used with Rust, and this is a database library that will allow you to execute SQL or SQL to different databases. So it's not a library to work with one particular database. It will allow you to work with multiple databases, but it's not exactly an ORM. So the difference between this kind of library that can work with multiple databases but is not an ORM, and then these kinds of libraries, which are ORMs, is that these are object relational mappers. They will execute the SQL for you, bring them into objects in your code, and then the way you interact with those objects would be methods and properties on those objects. So I didn't want to get into all of the details and split out the types of database libraries into different branches, as I didn't really feel it to be necessary. The main thing you need to understand is that you can basically do one of three different things. You can use a library to work with a specific database directly. So an example would be scopg2 with Python to work with the Postgres database. You may also hear of this as an adapter, basically a tool to connect your code to the database. Next up, you might have a library that somebody would write to work with multiple databases and give you some easy commands, but it's not an ORM. The main difference here is it doesn't abstract away the SQL itself. You are the one who will still write out the SQL language, and we're going to get into databases here in a moment, but you're going to basically write that SQL, and then the library will take care of actually executing that on the database and retrieving that data, bringing it into memory for your application. You might then have to do some manual mapping, taking the results of those queries and putting those into objects in your code. Finally, we have ORMs, which is the highest level of abstraction. This is basically when you will write something like users.getAll. You're not using the SQL language, but you're actually using whatever programming language you're working with. So if you're working within the context of a Python application, you might make your query in Python, retrieving the data from the database, and then bringing that into your code as objects. The ORMs have the highest level of abstraction, and it is often the way to easily get started working with databases, but they do have some downsides. They often do not have as much control because the
Yeah, so the problem with like problem with abstraction is that only, that if you abstract all the functionalities, you might not be able to get all the functionalities abstracted. You might lose on all the functionalities, or the developers are just taking time to complete all the functionalities. So till that time, or some functionalities are just too hard. So till that time, you will have a gap which you cannot fulfill. Um, but if you have less abstraction, um, all your because SQL commands are like too verbose and too time taking to write, all your commands will code development will be a little slow. So you decide where you want to fall, how much requirement or abstraction you have, because a lot of projects will not require a lot of complex uh, SQL queries, where so you should use ORMs. But when you need a lot of abstraction, you should not use ORMs. You should go for a library or just an adapter. So whatever suits the project.
Library authors give you a specific set of functions you can use. You're limited to those functions. They may give you an option to execute raw SQL, but that just depends on the library. This is usually fine for most applications. So when people get started working with an ORM, you get more specialized queries. You might not find the specific function you need, or behind the scenes, that function might not be executing the most optimized query, where the ORM could be doing something fancy in code that you wouldn't expect if you just executed the SQL directly on a database. This section of the mind map is really just designed to give you an introduction to database libraries, because I wanted to mention the potential concerns around ORMs. So you can do some additional research on ORMs. When you start to build out a project, you can decide if it's something you want to use. It is a great way to get started, but I highly encourage that everybody picks up SQL and has an understanding of the database at the database level and not just from within your application. So one of the sections we're going to get to will be databases, and that's an extensive list of the most popular databases. So we'll get to that in a moment, but for now, just be aware that within your application, you're going to need a way to connect to your database. That will either, or it will be an even larger library. If you're working with an ASP.NET Core application, this can help you generate your tables and work with data. That's another cool thing about ORMs. They abstract away a lot of stuff about if you're creating the tables yourself. Next up, we have Prisma. This is really popular in the JavaScript world. However, I have noticed that Prisma is growing beyond that to where you can use the Prisma syntax with other ORMs or libraries. So definitely worth looking into. I used Prisma within a Node or JavaScript environment, and I was able to use it to work with a Postgres database, QL support, and I needed to do something with MongoDB world. I just wanted to list two from the same language to show you that it's not used from, so major ORMs. All right, now I want to get into an interesting section, which is CMS, or Content Management System. And this is going a little bit away from core backend development, but is going to introduce a lot of interesting things that you should be aware of as a backend engineer. CMS is short for Content Management System. If you're not sure what that is, it's a system that helps you manage your content. Technical can use the CMS to create content and manage the website. So this is going away from custom web apps and getting a little bit more into content creation, but this is still an extremely popular thing you might need to do as a backend developer. Now, it's not often the case you're going to be working with these content management systems as a backend developer. You might, for example, you might be working in PHP for these three or C# with Umbraco, but another popular route is the headless CMS. So a headless CMS will give you just the backend, so the system for people to go in and create content and organize and manage that content, but it doesn't tightly couple that with a front end. So within the backend career, you might want to be familiar with these different CMSs because say one of these CMSs delivers the content as an API. You might need to configure that or set it up in a certain way or make sure the connection between that API and the front end is working. These are often coupled with a front end, and I put here SSG, which stands for static site generation. So it's often the case that these will be paired with one of these tools, which will be just the front end that will then make requests to your backend to retrieve the content to be displayed on the page. If this all sounds like crazy jargon, don't worry, you don't have to know all of the information when it comes to CMSs. I just wanted to leave it in here as a section because you should at least be familiar with the idea. So you can imagine, say you're familiar with WordPress. What if we had WordPress, but instead of automatically showing that in a WordPress front end, we just had a headless WordPress that delivered the content through an API. Then you could use one of these front end tools to consume that API and display that information on a page. So we're not going to get into the details of all of these different CMSs and static site generators. You can do additional research if you want in this, but we still have a lot of sections to go through. So next up, we're going to take a look at we'll go databases since we just got done talking about ORMs. This will help us kind of tie there. I've only listed some of the most popular databases, fancy marketing words, and it's sometimes challenging to understand what it is even for. So my goal is to give you an idea of what each of the major databases is for and how it's different than the other databases. That being said, the main way to categorize these is easy, either SQL or no SQL. SQL stands for Structured Query Language and is a programming language, but it's more of a standard. So all of the SQL databases will use the SQL language, but might have variations and things that are different between databases. Overall, though, if you learn one, you're going to be able to effectively work with all of them. Things might just be a little bit different in how that database works, or some of the data types or things like that. The no SQL, and this is confusing, it doesn't mean that there's no structure. It means not only structured query language. So some of the databases in the no SQL category might still have the option to use structured data, but they might have other things. And just to get started from the beginning, we have two down here, Redshift and Snowflake, which are a little bit different than the rest up here. They're all structured in that they store things in tables, and that's the main thing that makes something a structured database. But these two are largely prioritizing analytics. So if you have a lot of data and you want to run analytics on that data, you will use an analytical database. That's if the core features of these structured databases is not adequate, which usually it is, and you have some serious analytical needs, then you can look into an analytical database, or you might hear it as a data warehouse. So I didn't do it in this example, but if you wanted to, you could split this whole section up into two categories. OLAP, which is online analytical process, purchase, an interaction that you need to record, creating a post, basically the creates, the updates, and the deletes. And obviously, these databases are all going to be capable of reading data, but if your primary thing is just to read data and then calculate numbers off of that data, that's where you would go for the analytical types of databases. So transactional, analytical. I'm hesitant to do too much splitting though, because then it just becomes hard to organize. The main thing that these things have in common is that they're table based. So everything goes into tables with columns. There is a whole world that you could explore if you start looking down the path of Redshift and Snowflake, which are two popular data warehouses. Redshift is part of AWS. We're going to talk a lot about AWS here soon. And then Snowflake is another option out there. There's probably a lot more of these analytical databases or data warehouses. But the thing that I was trying to get to is that if you start exploring data analytics and data warehouses, there is a whole realm of information. And this is going to get you into the world of big data, which is going to talk a lot about things like data streaming. On purpose, because while you might explore some of that stuff as a backend developer, there is pretty much an entire different career path, or you could create an entire different mind map for the world of analytics. So that's going to bring in things like data engineering, ETL, and even some analytics like predictive scope of what I'm trying to accomplish and mix together. You most certainly might encounter some of those things, so you should be aware or needed a data warehouse or anything. You might not be able to do it at a very will be fine just to use a transactional database. So that's specifically if you really need to get into advanced analytics. Let's now go through the main transactional databases. I will just go from top to bottom here. SQL Server, it's the Microsoft database, similar to C# and Microsoft Azure. It's just an offering from Microsoft competing with similar things from other providers. So SQL Server is really good. It's been around for a while. I've used others on this list. So Oracle database, it's just the Oracle equivalent. Some database administrators probably freaking out that I just said that Oracle and SQL Server are basically the same thing. They're all databases storing structured data. As a developer, you're probably not going to notice a major difference switching between these two. As you get into the details, yeah, there's probably some really critical differences between them, but day to day, it's not going to impact us as developers unless you really get into more of differences with syntax and language will really come up if you start working with the procedural languages with databases. So a lot of these databases are going to have their own procedural language you can use to do more custom stuff. So if you need to do custom logic, you would use PL SQL for an Oracle database. SQL PL is the SQL Server equivalent, and there's probably languages for all of these. It's not something you're going to probably do a whole lot, but it might come up, and those are just languages specific to that particular database. These languages may come up if you're working with stored procedures and you're not just doing standard SQL, so there is a chance it will come up. I generally try to bring that logic into the application layer instead of leaving it in the database, but if you're in a company or an environment that's pretty database heavy, there's a chance that they'll leave some of that logic at the database layer, and you'll just have to familiarize yourself with that procedural language for that database. That would be
I also prefer bringing it to the database layer because uh, when you so for a backend developer to understand a logic, it's much easier than for a database engineer to go understand the syntax, what it is doing, and then understand it. It's not just a one look thing, it is a learning curve for a new engineer to come in and learn that syntax. Let's say someone who is working with SQL Server comes to an Oracle SQL database or MySQL database, and we are having those custom syntaxes present in the database layer. At that point, he will have to learn the database, like what those queries mean, and then understand it. But for a backend developer or an application developer, he would not have to do that. He will just have to see the code and understand because he already is familiar with the language. So that is a thing that I think that it's much better to have that in the application layer rather than having it on the database layer.
be for things like database triggers or procedures where you need to do additional validation or whatever it may be, but you're not going to be using the procedural language for day-to-day SQL, like creating rows or reading data, whatever you need to do for creating CRUD applications, for creating, reading, updating, and deleting. Next up, we have DB2. This is IBM's flagship database, and those are the three major enterprise databases. SQL Server is probably the most common of these three that is used by developers, but there is oftentimes you'll be working in Oracle or DB2 if you are in an enterprise setting. But it's often the case that Oracle, DB2, these are pitched to large enterprises with some pretty intense data needs. SQL Server kind of fills the middle ground between small-scale developers and enterprise. And then we have the open source databases, which usually will be the pick for first-time developers creating their own app. So hopefully that gives you a general idea of where these databases fit. It's kind of a generalization, so it's probably not always the case, but if you just want to know what people think about certain databases, these guys are enterprise. SQL Server is kind of middle ground, developer-friendly, but can still be considered enterprise coming from Microsoft. And then MySQL and Postgres, not so enterprise. These are open source. The main thing you should know is that MySQL is owned by Oracle. The original MySQL team forked MySQL, creating MariaDB. So this is kind of like a MySQL sticking to its roots, if that makes any sense. Basically, some concerns about MySQL now being owned by Oracle is that it's going to pull you into that Oracle ecosystem, trapping you for eternity, and some people don't really like that. Which, looking at this from Oracle's perspective, it's kind of funny if somebody can make a successful product just advertising that they're not in your ecosystem. So that's something to consider when you're looking into these databases. Do you want to be tightly coupled to a particular ecosystem? Doesn't mean you can't ever move, but things are just going to work better. For example, if you're SQL Server, if you're in Azure working with C Sharp, they kind of make an entire ecosystem, kind of like Apple and all of their products. All right, I'm kind of ranting. You can tell I like databases. If you're not sure which database to go with, Postgres is a great option because it's open source, it's free, and you can use it for free in a commercial setting. But my thought is if you're just starting out and you're trying to pick a database, go with Postgres. And if you need one of these other databases for some reason, you can switch over fairly easily because it's all based off of the SQL standard. All right, last structured database on this list is SQLite. You may also hear people say SQLite. I've always said SQLite. You may also hear some variations in pronunciation with Postgres, as the full word has a QL at the end, so you might hear PostgreSQL or variations of that. I just call it Postgres. So SQLite is a bit special because it's an embedded database. And what that means is it's delivered with the software. Now, for a backend developer, you probably won't use SQLite for the majority of the applications you build. And that's because you're building a system. You can imagine that system over here, and lots of clients connect to the server. So you have a single location, and that's going to host the database. SQLite would be a popular choice if you were delivering software to a bunch of clients and they actually ran it locally. So instead of having a centralized server, you actually distributed software, and that software needed a database to store some information locally. That's where SQLite would shine. You can use SQLite for centralized storage, but it's not the first choice. That being said, I have learned SQLite. I think it's a great option to learn and practice with. It's super easy to use and set up because it doesn't have a dedicated database management system. It's really just a file on your computer. It's super easy to start working with databases when you're working with SQLite. It's even included with some programming languages. So for example, if you're working with Python and you want to store some data in a database, you can just use SQLite immediately without having to go install stuff and get things configured and set up. So that's one of the main reasons I like SQLite. And it's also good to understand what people mean when they say an embedded database. It doesn't always mean embedded systems like people are talking about when they say they're an embedded engineer working on IoT devices or something like that. It can just be regular desktop software. I like to think of it more as the database is embedded with the software and it's not at a remote destination acting as a server client setup. So I'm pretty sure that covers the core SQL databases. I'm sure there are more out there, but again, you know exactly how they're going to fit into this larger structure. Next up, let's talk about NoSQL databases. And this one can be a little bit overwhelming because these don't all have core similarities like the structured databases. A lot of these are just competing products from different companies, other NoSQL databases. And sometimes there are competitors. So a little bit more complicated, but we're going to work our way through this list, getting a basic idea of each of these. Now, just so it's clear, and I think I've made this point already, you do not have to get experience with each of these. I have not used most of the databases in this list. It's really about becoming good at a few of these and using certain ones for certain use cases. So when you have some application and you know you might need to do X, Y, or Z, you can read into database. And what a document is basically key value pairs, pretty much like an object in JavaScript. So this is going to be pretty similar to beyond just JSON. So you can look up the BSON spec if you wish, but you can tell this is describing what looks like a person. It has their age and their status in groups. The main difference between a NoSQL database and an SQL database is that there can be differences between individual documents. So the next person you put in this collection could have a name and a structured database. You're going to define the columns, which will be their columns. So that's the major difference. If you have variation in structure between documents, then it makes sense to consider a NoSQL database. MongoDB is pretty much the same idea provided by Amazon. So AWS Document DB, it's going to allow you to store documents. And what that means practically is that Document DB is a managed document. When we talk about Document DB, MongoDB is one of much the same idea. Access that database and pay for it as you use it. Compare that to MongoDB. While you can get cloud offerings, you're not required to. So you can download MongoDB, host MongoDB for you. So that's always an option as well. Now let's take a look at IndexedDB. Not really sure why I put those between the two, but no big deal.
Exactly.
IndexedDB is a database in the browser. And this is really kind of cool because it allows you to store information that the user that is using your page might need to store temporarily, giving them a consistent experience between visits, but it's not something that's persisted to the backend. This gives you a database structure in the browser, and that might be more useful than just using something like
Yeah, so let's say you have an application which takes a long time to load. So in that case, what you can do is, and you want to use, thank you, bro, thank you, thank you, thank you, thank you. Um, so let's say, as I was saying, you have an application which brings in data, and you don't want the data to always load. It does not change a lot. It changes, let's say, in every 2 days it changes. Let's say it's Amazon, and you have listings of things, and if you search, let's say, water bottle, you want every time the water bottles should be listed in the same way. Perhaps after 2 days they could change. So in that case, you will just store it in the IndexedDB on the browser, and if water bottle is searched again, um, you use it. like you use that data that is not stale from the index DB. And after 2 days, if a water bottle is searched again, then you update this data also with the data that is brought in by the API. So that's how you reduce the API calling, and that's how you optimize your front end back end relation. So that's how you do it.
local storage. Now, I generally wouldn't recommend this for any critical information because it's local to the client, meaning
Exactly. So let's say you are building a portfolio site for yourself. So in that case, it would make sense to just add that data because that will allow your site to load faster on their uh, PCs, and uh, it's just a static site. So, and if you have that data, but if you are building, let's say, a stock trading app, it does not make sense to use index DB, obviously, because you want each and every millisecond or a second millisecond the data to change.
they could disconnect from the server. They're not going to be able to give that information
Thank you.
to you, and because it's client side, they can access that information as well. So it's not something you would use for storing critical information, or if you needed to make sure that information was persisted indefinitely, you would not want to use this because the client could never come back, or they could clear all of their browser stuff, and then they're not going to have that data any longer. CouchDB offers some interesting similarities between IndexedDB. Now, I wouldn't say these are a direct comparison, but one of the selling points of CouchDB that makes people use it is it will allow people to store data locally, and then if they later regain a connection to a server, they can then sync their local data with the server. So if you need that offline experience, but you still want to store data in a centralized location, a server, then you might want to check out CouchDB. Next up, we have Neo4j.
Oh, nice. So let's say you have an Excalibur-like application where you do things and build things, but if I turn off my internet, still Excalibur will work and it will store something, the things. So I think they are storing it on. Uh, how do we open that? Where is where is inspect element? In inspect short control shift C control control options C. Uh, mm, Come on, option I. Come on now. Yeah. So where does Excalibur? So let's just check this out. There is one local storage. Yeah, I think it's in local storage. Excalibur. Yeah, it is there only. So it's in local storage. So if they can store it in local storage. They can also store it in uh, IndexedDB. So IndexedDB, we can go application. Yeah, so local storage is here, and we can also store it in IndexedDB. IndexedDB. Yeah, so they have some things that are stored here also, or they have tried, but doesn't seem there is much data here. There's some cache, or if they are, I don't know what is the maximum size of cookies, but they can store it in cookies, shared storage, cache storage. So multiple places where these storages can happen. So CouchDB is also one of that thing where you can do it, and CouchDB also.
And the best way to describe this
CouchDB is not a JavaScript solution, it's an external solution.
besides saying that it's a graph database, is to show you some of the examples from their website. So here are some of the use cases, such as knowledge graphs, accessing deep dynamic context by connecting data. So this really shows how data is related and can lead to some really cool visualizations if that's something you're interested in. You can see a basic example here showing how things are connected. Here's a visual I was able to find without
So social networking sites or task management sites, graph data is much good. If you are making a software like Jira, where you uh, are using Scrum, so you want to make a software to build a project management site, like project management tool, like Jira, you can use GraphDB.
actually going in there and creating a database. You can see that it shows the nodes and how they're connected and it has like this cool liquid movement thing. But yeah, that's an interesting project you might want to check out. Next up, we have DynamoDB. This is a serverless database provided by Amazon. The whole idea of something being serverless is not that it doesn't use a server behind the scenes, more so that you as the developer are not responsible for the server. It's kind of like a managed database, but it's completely managed where you don't even provision a server that someone else manages. You don't provision anything. You just pay for the use of the database. So it's a key value NoSQL database, giving you single digit millisecond performance at any scale. And that's obviously one of the selling points because it's serverless. You just pay for what you use if you need to scale it up or scale it down. And the idea with serverless is no cold starts, version upgrades, maintenance windows, patching, and no downtime. Bigtable is a product from Google and is the inspiration for Cassandra and HBase. So this is different than some of the other databases out there because it specializes in wide data. And by wide, we mean lots of columns. So if for some reason you have some data and you need to store thousands of columns about that data, you might want to look at something like Bigtable. This is a fully managed database from Google. Cassandra took some of these principles and designed it to be a fault-tolerant database. So this is something that will be replicated across multiple nodes and can support basically a distributed system using commodity hardware. So you could have thousands of nodes and they don't have to be expensive servers. So you can read about some of the use cases or case studies with Cassandra. I think Apple at one point said they had 75,000 Cassandra nodes supporting 10 petabytes of data. So this will basically enable a company to have a distributed system, making that possible with commodity hardware with a higher node count, comparing to paying for just a couple really expensive.
Yeah, Cassandra so- is used by some yeah, Apache Cassandra. It's from Apache distributed database.
Servers, for example. So this is decentralized in tech, but it's not decentralized in ownership. So these would also be owned by Apple, which is just something interesting if you ever do research in like decentralized technology or blockchain. This is a little bit different where it's still all the same owner of the data. It's really just about decentralizing the data across a substantial number of nodes. HBase is similar in idea to Bigtable and Cassandra being a wide column database. However, the difference here is that it's all within the Hadoop ecosystem. So if you have no idea what that is, probably don't worry about it right now. But again, as I mentioned earlier about analytics, this is an entire environment around big data, and you might run into HBase if you're working within a Hadoop environment. Otherwise, I would look at some of the other options here. Next up on this list, we have SurrealDB, which is a newer database that you may have seen people talking about online, or maybe it's something you will run into. But the target audience of SurrealDB is not entirely clear because it's kind of a database that does everything. So that's really their marketing. It's like the database that could replace a lot of other databases you might be using. So it's the ultimate multi-model database. They definitely have good marketing and branding, but it's probably up for you to decide if it's a great database or not. With full graph database functionality, SurrealDB enables more advanced querying and analysis, which allows for multi-table, multi-depth document retrieval efficiently in the database without the use of complicated joins. Next on this list, we have Redis, and this is definitely a good one to know, so be aware of it, but I would encourage you to try it out and become familiar with it because Redis is an in-memory cache. That's what it's primarily known for. Redis has a variety of other things it provides and can do, but the main thing Redis is known for is caching of data, so you can make your backends faster or use less computation by not having to retrieve or compute things that you've already computed. So in-memory cache, very valuable for improving the speed of your applications. Now, if you're using Redis purely as an in-memory cache, it's going to likely be used in addition to some other database. So you'll have some database that's powering your backend application. If you wanted to visualize it, you could then think
Yeah, so if you want to learn backend development, uh, if you know JavaScript, first thing, like or a language, so not JavaScript itself, but a language, you can go here and go to roadmaps.sh, which is a great um, what do you call this? Great place to learn. Great source, like great content. I don't know what do you call these things, but yeah, yeah, it has a lot of roadmaps where you can learn how to do things and what to do. Uh, I know, like uh, sometimes I think that there are many teachers out there which are trying to teach a lot of things, but I think the most simple things are these free tools. So if you want to learn backend, you could just go to the backend development roadmap. It has everything, and it would make you a very good backend development. So let's say his video only is it's very inspired, seems very inspired from this. You see, it has a lot of things that are same because technology is the same. Technology does not change, and he has his own experiences with different technologies, so he has added those ones. But at the end, it's the internet, it's the language, it's the version control, it's repo hosting services, it's the caching, it's the database, it's APIs, web security testing, CI/CD, databases, design, patterns, all things at the end will remain the same. So I think roadmaps.sh is the best uh, tool to learn anything. Um, yeah, and they have a lot of things. So you are from biomath, bro. Man, honestly, JEE पढ़ लो भाई. If you want to get into tech, first try to get into a good college. That's the main thing. Um, don't try, like I have been a person who has been always very interested in technology, and because of that I did not study well, though I had like good percentile. I had 96 percentile, but at the end, you don't get into IIT in and get computer science with 96 percentile. So or NITs you don't get computer science. So at the end, JEE पढ़ लो.
Think of Redis as sitting between your backend application and the request from the client. So it will first ask Redis, hey, has this value been retrieved or calculated before? If yes, we'll just give that value back to the user. But if it has not, then we'll go process whatever needs to be processed, retrieve new information from the database, and then give that to the client, caching it. So if anybody asks for it again, we can just get that cached value. Now, when we say in memory, that just means this is not persisted to disk. So if the Redis server is restarted, all of the data that has been cached will be reset. And this is generally fine. Resetting a cache or clearing a cache is a pretty typical thing you would need to do anyways, so it's not the end of the world if your cache is cleared. You're not storing anything in there that's critical that you couldn't lose. Now, I did mention Redis can do a variety of things. So, for example, you can have it persist data, but when people think of Redis, they usually are talking about an in-memory cache. Now let's take a look at memcached here. This is another in-memory cache, so this could be seen as an alternative to Redis. While it's also pretty popular, it's not as popular as Redis, and if you were to choose a new caching system, you're probably going to go with Redis, but if you even go to get hosted Redis, for example, you might see memcached as an alternative option. So there might be some specific scenarios where memcached shines, and I don't want to say to never use that, but Redis is going to probably be your default choice. Now, Elasticsearch, we're going to keep this real simple. It's a NoSQL database used for searching data. So if you have some complex data set and you want to be able to full text search it, you could look into Elasticsearch. Now let's take a look at Firebase. And really, there is like a couple of different products within that. So there's Firebase Firestore, which is the default choice if you're going to go with Firebase. But you might also hear of the other option, which was Firebase Real-Time Database, which is still an option to use, but pretty much in every scenario, you're going to go with Firebase Firestore. So here's a quick comparison, and just scrolling through this, you can see that Firestore is preferred in every one of their scenarios. So they are pushing to use Firestore and to not use the real-time database. But without getting into the details of the differences between these two, let's first talk about what even is Cloud Firestore and when you might want to use it. It's another JSON-compatible document database. Now I'm going to explain one of the reasons why I believe Firebase has become so popular. While I'm sure there's lots of other features and capabilities, when there's millions of different databases, what is the reason Firebase has taken off? It's because it's very useful for what I would typically say are primarily front-end developers, because the entire Firebase ecosystem is a good ecosystem to provide an entire backend.
So Firebase or Supabase are seen as backend as a service, and Supabase is an open source alternative for Firebase. Free or much cheaper, I guess. I'm not sure how free or cheaper it is, but from what I remember, it's much cheaper or free version.
So when you use Firebase, not only do you get that database, but you also can get a backend layer, which can make it very easy to have a backend to connect your front end application to. So you can almost think of Firebase as a backend as a service. You can just use Firebase for all of your backend setup, and you just worry about the front end. I've seen a lot of content creators on YouTube basically using Firebase so that they can focus on the front end material, not having to build out an entire backend from scratch. It's also extremely popular for mobile applications as well, so you'll often see Firebase being the backend for mobile app devs. Now, one more important thing to know about Firebase is that it is a managed backend, so this is hosted on the cloud by Google. It's a Google product, so it's going to be something that you have to connect to the cloud. You don't download Firebase on your local computer. However, that's where Supabase can come in, and that is positioned as an alternative to Firebase that's open source. And the magic here is that you can get it hosted or you can self-host it. So it's something that you could download, put on your own server, and use as you please. This means there are also multiple options out there when it comes to managed Supabase hosting. Most likely, though, if you're looking for fully managed Supabase, you'd probably just go with the Supabase company themselves, who offers hosting, or self-hosting it with any of the other major cloud providers without having the managed aspect. Throughout this video, we've talked about hosting some, but we haven't really gotten into the details of the different types of hosting and what that looks like. That's what we're going to talk about next. Now, as always, when you're doing a video that covers a billion different technologies, it's kind of challenging not
This first year, I'm starting to learn Nine. Yeah, I just need roadmap where to learn right now. Yeah, it's your choice. But I would not suggest to learn coding. If you want to just like learn development per se, if you want to learn C++ or something, that's good. But I think the conventional route of doing good in J is good. Or just if you if you like development so much, then in that case, you can just come into development and not go with the college route. That is also an option, but it's much riskier. And who knows? Uh, who knows what works, what does not? I cannot guide you or give you a solution for yourself, but these are just my thoughts.
to overgeneralize or potentially not have everything 100% split up into the perfect categories, because some of the things we're going to talk about will probably cross over into some of these other categories. So if you're a rep from as a developer, often these services will provide a variety of different things. But what I try to do here is kind of categorize by what these companies are most known for. So first, let's get the foundation. What is hosting? Basically, if you want to run a web server or some application and you don't want to run it from a computer in your house and have people connect to it over
Oh, okay. I'm first year high school student at IT. I don't understand. Uh, are you in college or are you in high school? Uh, so for me, college is after 12th. Like that is what I call college. Uh, I know somewhere in Maharashtra people call 11th and 12th also as college, but I think you are in BTech, so it's like college, not 11th and 12th. I completed 12th, yeah. So you have completed 12th. So yeah, so I guess start by learning C++ plus plus if you don't want to get too deeper into technology and just want to make websites, then you can skip C++. plus plus. You can just learn JavaScript and then yeah. So start by learning C++, or you can skip it if you don't want to get too deep into technology. You can just learn JavaScript, and once you have a good command on JavaScript, you can just follow any of this path. If you want to go more into enterprise side, which I would suggest, if you want to make better money or have better options. So at least you want to have better options. I would not say money, but better options. Better stable options. Let's say stable options, not better, but stable options. You should go with Java. That would give you much stable options. Rust would give you much high-end options, but the risk is actually very high. The reward is also very high, the risk is also very high. Um, Go would also be high reward, high risk, though the risk and reward both are much lower than uh, uh, Rust and Go. JavaScript, a lot of people do JavaScript. So that is your disadvantage, that the competition is high, but the market is very much there and um, compared to Go or Rust, and the salaries are good. Java would be one of the good options because a lot of banking companies use it, and so you will have a stable job. You'll not have a problem with finding jobs. So that if you want that stability, then Java is good. And yeah, that's my 2 cents.
the internet, you can host that application. You pay money to a hosting provider, they run all the services, and then people can connect to it there. We have three general categories I group these into. So we have the shared hosting companies, we have platform as a service, and then infrastructure as a service. We'll get to those two in a moment. Let's first talk about these shared hosting providers. So when I sign up for shared hosting, I may run, say, a WordPress website, and there might be a lot of other people running WordPress websites from the same server sharing resources. So you can think of your application as just one of many applications running on that server. All the resources are shared, and there's no real separation from the different websites. Now, while there's probably things set up to keep things secure between websites and make sure one website doesn't impact the others, that is a potential risk. So if you're paying for shared hosting and it's sharing resources with another website on that same machine, let's say something goes wrong with that other website and it starts to consume too many resources, or maybe there's a security issue, there's a chance that
Uh, Nothing. None of these. If you want to, that is your path. Leave. Just leave this. Like I know I'm doing this because I like it. Okay. But if you want to go with Mang or like some good company, pick C++, Java, or Python. I would say Python because it is much easier and faster to type. Just because of that, I will say Python. But C++ or Java would be much uh like memory wise, C++ or Java would help you a lot in being a better coder. But Python would be faster to write. So any of these three, whatever suits you, and start just doing lead code. So do lead code, do it every day. Make it a goal in your life to do lead code. That is the only thing you need to do. If your CGPA is good, eight above, and your college is good, I don't know what your college is, but if your college is not good, then you would might not get chance in college, but you'll get a chance after 1 or 2 years of working. But if your college is good, just do lead code, and that's your roadmap, bro. Uh, do 1,000 questions. If you are in first year, target 300 questions per year. And yeah. So no, competitive coding is algorithmic based. So when you are doing, let's say, you are making a website, you're making this Chrome browser, you're making this calendars app, that all comes into full stack development. So full stack, generally people now refer to websites, but all of this thing comes under website development, full stack development. Competitive coding is just solving this problem. So it's not competitive coding. So DSA, data structures and algorithm, is solving these problems. Okay, these problems, whatever you find, like all these problems, solving these problems is called data structure and algorithm. But if you go on code forces, so if you go on code forces, now here solving these problems uh, or participating in these competition is called competitive coding because you are competing with, like, let's say 1 lakh people around the world, and that's what competitive coding is called. So Code Forces is one site where you can compete. There was also Google Kickstart, which now has closed. Then there's Code Chef where you can compete. So they also have competitions where you can compete. So that is competitive coding. And uh, what all resource can I give you regards to competitive coding? So your but for competitive coding, you will have to make your DSA strong, and with that, you need to compete also. So competitive coding has two steps: make your DSA strong and compete. And um, yeah, Mang would not accept full stack development. So it's like only Microsoft has this program called Microsoft Engage, which comes in second year of college. I missed it. I regret it so much because I was so good at development at that time. But Microsoft uh, has this Microsoft Engage, which is a development-based hiring. Apart from that, no, Mine does not hire based on development. They hire based on competitive, DSA, not competitive, but DSA. But competitive does help in DSA. And on top of that, uh, Google, on the other hand, for 5 years of experience also does not hire you based on your development skill. It will only ask you DSA. So even after graduating college, working for 5 years, if you are applying to Google, you will not need to have any full stack skills. So don't focus if that is your goal and you think you can do it. Do not focus on development. Focusing on development is not a good strategy. But if you like it, like me, I generally do things that I like. So that's step intern. I think step was also yes, sure. Yeah, I think step was also based on DSA only. Uh, uh, I don't remember step internship, but I think it was DSA. 45 minutes. It seems like DSA only. Yeah, DSA based questions. So no need for focusing on development. For your college placement also, if you're wanting placements, you don't need development. If you're wanting to go into startups, if you want to build your own business, uh, if you have a product, then that's your way to go. Then development is your way to go. Yeah, I do that for improving my consistency. Thank you, thank you, thank you. I also I would like to like grow my YouTube channel some like slowly and gradually. I would like to make more professional videos also, but right now I am not that interested. So that's CIT Chennai. I'm not very sure about that, but uh, that's your college. Uh, I've not heard about CIT. Uh, it's just I am doing this. I like it, and I with that I can also stream. So if I grow this channel, if I have 1,000 subscribers, after that I would make a much more polished videos. If I have 2,000, I'll make much more polished. So that's the goal of going with this.
could impact your website. While it's ideal that that doesn't happen, or that, there's some things in place by these hosting providers to make sure that doesn't happen, it's not something that would likely be guaranteed. And because of that, some people avoid shared hosting. Not only does shared hosting limit your resources, but you're sharing the machine's resources with other people. It's the cheapest option, and this will give you things like hosting for a few bucks a month or whatever it might be. The way the companies package the hosting changes, so on one website you might pay per website, or you might just pay a certain amount and get unlimited shared hosting. So then you can set up as many websites as you want as long as you're a paying customer.
So probably Mang would not come to your college. I'm not very sure. I think Amazon used to go tier 3 also, because at the point Amazon used to hire a lot. Right now Amazon is not hiring. Uh Thank you, bro. Thank you for your wishes. But you might get chances after you join work. Now, if you want, like, now then, if that is not an option for you, I think development could be option, good option for you, because then you can get into startups easily with development, and then you can uh, still practice DSA, because bro, like it's sensible now. Like you have to study sometime. Like you didn't study in school, you will have to study in college. You didn't study in college, you will have to study. You will have to work harder. So that's how I see it. So if you can manage both development and DSA, then after job, after you get a job in 1 or 2 years, you might get a chance to interview for FANG or MANG, and that's how I see.
The big ones on this list you might be familiar with: GoDaddy, DreamHost, Bluehost, SiteGround. These do all basically the same thing, and I don't really
My wishes to you too, bro. My wishes to you too.
have a recommendation on which one to go with. I've personally used a lot of DreamHost, I've used Bluehost, and I've used GoDaddy. All have been pretty good. I've also used Hostinger. I hosted a Minecraft server from Hostinger at one point. That was pretty cool. 99% of the time, you're not going to be using shared hosting as a backend engineer. This is really if you just want to launch a simple website and you don't really want to do anything with custom backend coding. You might be able to do some WordPress plugins or a very limited set of options, but most of the time it's going to be very limited. So that's where the idea of a virtual private server comes in. And often it's the case that you'll go from shared hosting and then upgrade to a VPS. This is where you get basically a dedicated server, but it's virtualized. Behind the scenes, they might be running multiple of these virtual private servers on a single server. So there's some limitations. However, it's pretty much a dedicated server from your perspective. So this is where you can basically have a Linux
Thank you, man. Like now.
server, you can run whatever you want on it, and because of that, you can run custom APIs or anything that you need from that server. Now, when you're doing this, you're kind of in control to manage the inbound and outbound of this, and you're likely going to need some kind of web server. We'll talk about some of the most popular web servers here in a moment, but just letting you know that you're kind of in complete control of that environment. Next up, we have dedicated servers, and this is pretty much what it sounds like. They host a server and you pay for it monthly. You can do whatever you want with it. It's not virtualized, so you're not sharing resources with anybody else. You can research why you might want to go with a VPS versus a dedicated server. It often comes down just to what you need and costs. In this scenario, you're basically just paying for the infrastructure. So it's kind of infrastructure as a service, and we're going to talk about more infrastructure as a service in a moment. Whenever something says as a service, it basically just means a subscription payment model. They're running the computers for you and you're paying a monthly fee to use them. However, as a backend developer, I don't tend to think of these companies when I'm looking for my backend hosting solutions. Yes, you might run into that, but most likely you're going to look at one of the major cloud providers for infrastructure. So Amazon Web Services, Google Cloud Platform, Microsoft Azure. Those are the major three. There are a few others we'll look at, but those are going to give you a lot more services, and you tend to really think about those when you say infrastructure as a service. So we'll get into this next category here, which is PaaS. This is platform as a service. And here are some of the most common ones you're going to run into. As always, there are a ton out there, so this list is not comprehensive, but Vercel, Netlify are two really popular ones right now. And then we have a lot of these other ones from major companies, which will often help you deploy apps onto that particular cloud. So we'll talk about what that means in a sec, but for Vercel and Netlify, basically you can think of them as abstracting away all the computer hardware, and they just give you a really good experience for deploying backend applications. And often you can do front-end stuff as well, API. You can do it on these platforms, and they're going to make the experience as easy as possible. That's really what you're paying for when you're paying for a platform. So to explain the difference real quick between a platform and infrastructure as a service, platform makes the experience very easy. It's basically a wrapper around infrastructure, whereas if you're paying for infrastructure, you're in charge of setting deploy experience. So Vercel, Netlify, to my knowledge, do not run any servers on their own. They are going to use the infrastructure that without you having to go into AWS and set up a bunch on AWS directly. That might not be 100% true all of the time, especially if one of these platforms are able to provide some special pricing or, perhaps set up the infrastructure in a way that would save money compared to how you might set it up if you did it on your own. Or they might just be reducing prices for customer acquisition. You can go to one of these platforms, do something cheaper than if you went to one of the cloud providers directly. Heroku is another one that's pretty similar in concept to Vercel and Netlify. I guess I just didn't see it at first in this group because I had it
Mhm.
prefixed with Salesforce. I wanted to put Salesforce there because I didn't even realize Heroku was owned by Salesforce until recently. So Heroku is another platform as a service that's going to help you deploy to some of the major cloud providers. Now let's take a look at this next one here, AWS Elastic Beanstalk. This is a platform as a service on AWS, so it's going to make the experience deploying to various AWS infrastructure a lot easier. So while AWS provides an idea with these other ones, so I'm not going to go through EF4 Google Cloud. Then we have DigitalOcean App Platform. I think they host their own stuff, so they use their own infrastructure. Same idea with Oracle
Mhm.
Cloud Platform with the Oracle Cloud. So let's take a look now at the infrastructure platforms. These are the major ones. So we have Oracle Cloud Infrastructure, VM Cloud, Alibaba Cloud, DigitalOcean, Akamai or Linode, and there's a ton of other ones out there which I mentioned briefly, but some of these are as easy hosting providers. And then I kind of think of this group here as companies where for $3.99 a month or made it through three major sections in this center section. And then we have these two floating over here on the sides. But let's go through the next one, which the logical next one is going to be clients and servers. Since we were just talking about hosting, what web server software is actually used? Well, if you're working with the infrastructure directly or you have a dedicated server, you're going to be responsible for choosing what web server you want to use. And the web server is what actually handles requests to that computer and makes it possible to run applications from that computer. The three major ones I'm familiar with are Nginx, Apache, and IIS. There's also Caddy on here, which I've heard a little bit about when I was just researching different web server software, but I haven't used or experienced that directly. And
Mhm. So there are a lot of languages which have a web server bundle. So in Node, if you want to start a server, you just write code and it starts in Go. It writes, it starts. But let's say in C++, the server is not bundled. So you will have to use one of these web servers to serve that code.
as always, there's other ones out there, I'm sure. But these are the big ones you might run into. So let's just talk about IIS real quick. This is a web server that's really popular for ASP.NET and Microsoft applications. So if you're not doing that, then I would probably go with one of these two in the middle. I have used both of these a bit, but I've grown to kind of like Nginx. Really, it's just about getting them set up and then probably never touching them again because they work. You might have to do a little bit of stuff with like SSL certificates and maybe some configurations for routing or redirection. But overall, you're not going to be doing a whole lot at this level. Hopefully, it's just something that you can set up once and it works. This is where more differences show up between using infrastructure and using a platform. If you're using a platform as a service, there's a good chance they abstract away all the web server stuff for you, so you don't have to even think about setting up Nginx or Apache. It's just done. The difference is if they just hand you a virtual machine or a dedicated server, you're going to have to learn how to set all that stuff up yourself. Now let's talk about things from
Yeah, so you can see I'm not very sure about these servers, but Nginx is also called a reverse proxy. So Apache, let's just see. Apache web server, no, HTTP server, and you can serve your static sites from here. Um, Basically, it opens a port and where you can request data from. And yeah, so a lot of languages now have their own server, but Nginx is also used as a reverse proxy, distributing traffic to multiple backend servers. So basically like a load balancer. And so that is why Nginx is very popular right now with JavaScript applications especially. Um, so all these things are done by Nginx.
the other end. So the client that actually makes a request to the web server. So when I say client here, I'm specifically referring to the software that makes the request. So the browser, that's going to be the case majority of the time. People are going to make requests to your web application through HTTP or HTTPS, doing that through a browser. So I group these in three different categories, but if I expand these, it'll basically just be the major JavaScript link v8 JavaScript code within the browser, and you're probably going to get a more consistent experience between these four because they all use the same JavaScript engine. Now, just to get sidetracked for a minute, if you're studying JavaScript and browsers and engines, you might hear the term runtime. V8 is not the runtime. You can think of the runtime as where the JavaScript code is executed, so you could say the runtime is the browser here. But if you use Node.js or backend JavaScript, the runtime is actually Node.js. And the engine is still V8. So we still have the same core JavaScript processing. It's just the location has changed from front end in a browser to back end with Node.js. So just saying that to be careful not to say V8 runtime, it's the V8 engine. Not to be too picky on words, but you might hear people say one or the other, and just wanted to clarify what is correct. Now, as for the words WebKit, Blink, and Gecko, you might hear these as the rendering engine. They are what take the HTML, CSS, and JavaScript and make it functional in the browser by providing different browser APIs and different things you can do with JavaScript. So it's a partnership between the JavaScript engine, which provides the language and the execution of the JavaScript, and the rendering engine, which provides the APIs and the DOM. So while this isn't really designed to be a tutorial on web browsers, it's just important to know that behind the scenes of these common web browsers, there are a lot of things going on, and the introduction of a web browser has changed a lot of things. As we go on, web browsers are becoming more powerful and more standardized and readily available on more and more systems. This is kind of similar to how operating systems abstract away differences in hardware. One layer higher, browsers abstract away differences between computers. So you can create an application to work correctly in a browser, and we don't have to worry about whether it's being ran on Windows, Mac, or x86, or ARM-based systems. We just create it to work in JavaScript with these different JavaScript engines and rendering engines. You may also hear of the set of browsers as Chromium browsers, which is an open source browser project that Chrome was built on. So that scratches the surface of web browsers. There is a ton more on how web browsers work. A waste of time in terms of studying as more and more CDNs, which kind of sit between servers and browsers. So if you make a request from a browser to hit somebody's web server, you might go through a CDN, which stands for Content Delivery Network. Here are the most popular ones. You've probably heard of Cloudflare if you've worked in backend development at all. And then we have CloudFront, which is Amazon's Akamai CDN, Azure CDN for some infrastructure as a service. We didn't talk about it specifically, but you can look up Cloudflare Workers. This is their serverless compute option, and then they also have R2, which is their storage. But let's not get back to infrastructure. Let's focus on CDNs here. The CDN is a content delivery network, and its purpose is to do two things. The first of those two things being edge distribution. So if you imagine a graph and you have a bunch of different locations where the center might be your web server, the CDN is basically going to copy the pages that people request and distribute them to all of these different locations so that when somebody closer to one of these edge locations makes a request, they don't have to go all the way to the main server. They can just request it from an edge location. Now, in general, the internet is very fast. You can make a request to something on the other side of the world and get a response relatively quickly. But if you're building a service and you want to make sure the times for loading are as quickly as possible, the less distance the request has to travel, because there's actual networking for these requests, the faster the response to that request is going to be received back by the client. So this can drastically improve performance. So that's the first major thing. And then the second major thing, which is included in this concept, is caching. So when someone makes a request, instead of having to recompute that information, they are just getting a cached version of that page, which is going to be a lot faster because there doesn't have to be any computation or requests to a database. Now, caching is a more challenging topic when it comes to backend engineering, and it's probably something I'd like to make a dedicated video on, like all the different layers of caching, database caching with something like Redis. So there's a lot of different spots where information can be cached. If you're ever in a scenario where you make some change, but you're not seeing that change reflected, there's a good chance it's being cached. To fix that, you may have to clear some caches. So if you deploy a new change to your API, there's a good chance you'll need to go into Cloudflare or any of these other CDNs, clear the cache so that the new pages and the new requests get sent to the edge nodes. And then you could also have questions about, do you cache the actual API responses or do you just cache front-end pages?
A good product would be to make a cache system which, when updates, makes the old cache invalid. So, let's say you build a product. I think this would be done at the level of cloud providers only, where if they are providing a CDN service and the yeah, so Cloudflare or something, these could develop products which invalidates the uh, uh, old cache when redeploys them. And I think some of them also do that, but a lot of them don't, or don't do it as fast as they would want. So it takes at least like 1 or 2 hours for the caches to get invalidated, and then um, or sometimes much more, and then it is a little bit frustrating.
And these are
I have faced that problem with my work, so yeah.
all things that you can have control over. The main thing you need to understand is that at any level of caching, you'll need to clear that cache if you need new changes to be propagated so that users get the latest data. So that's your basic intro to CDNs. Definitely an important topic to be really familiar with as a backend engineer. Now, another section that may be interesting to add in here that I did not put in here would be internet service providers, ISPs. These are the people you pay for internet access. And I say that because ISPs are responsible for the routing between these different sections. So when you make a request from the browser to some server on the other side of the world, it's because of your ISP that that request is made possible. I didn't want to put that here right now though, because I didn't want to get too much into the physical networking, because it is something you can kind of just abstract away from your mind. You just know that requests go through the magical internet black box. You don't really need to know all of those details as a backend engineer, but if you are working in a role that might be a little bit lower level, working at the network level, you may benefit from having a deeper understanding of how the actual internet networking works. I obviously decided to leave that out, but just wanted to give it a quick mention if it's something you wanted to spend more time studying. That wraps up the section on clients and servers. Up next, we have communication, the language or the way you decide how to write things that you can communicate. You still have to have the same language. One would be the means of communication to communicate. have experience using all of these, but you should at least be familiar with these. Now, I say this with pretty much every section. There's probably a lot more. In software engineering, there's pretty much unlimited information. So don't feel like you have to know everything what that is. That's actually probably a good one to get experience with. But so if somebody says, webhooks, you know what that is. That's actually probably a good one to get experience with. But for example, if someone says a SOAP API, you don't want to be like, what? I already took a shower today. Like, what are you talking about? So we're going to give you the basics of what each one of these are, but you don't need to go and actually implement all of these. There's just a few you
I think this is an important topic, learning about the different kinds of API.
should really have experience in. So let's first talk about REST APIs because that's going to be the most popular. This stands for representational state transfer, which basically is a way to transfer state or data through HTTP or HTTPS, which is one of the protocols we're going to talk about here in a moment. So the way you do this is you associate a particular verb, you can kind of think of it as. The official term is HTTP methods, but you can get data, you can post data, you can delete data, put data, and there are a variety of other HTTP methods. This describes your intent when you make a request. So when you go to a website such as youtube.com, that is a GET request. You're requesting the HTML, JavaScript, CSS from the server. There's also scenarios where you post data, or you can think of it as create data, and this would be submitting a form. In that situation, you're giving information to the server, and you associate that with an HTTP method, so the server understands how to interpret it. When you're building a REST API, you're going to make endpoints on the server side to accept different request types. So the user, the end client, could receive data with a GET request, or it could give us data with a POST request. This is often going to use JSON, which is the notation. That's basically the syntax for transferring data back and forth, and this is probably something you're familiar with if you've done any backend development. So REST, it's a really good thing to know. You should probably prioritize that here first. So let's talk about SOAP real quick. The only thing you really need to know is that this was the approach to building APIs before REST, and it used XML. So REST is the modern replacement, and you shouldn't be creating a SOAP API at any point. Now that's a general statement. There might be scenarios where you need to build a SOAP API to need to know is that this was the approach to building APIs before REST, and it used XML. So REST is the modern replacement, and you shouldn't be creating a SOAP API at any point. Now that's a general statement. There might be scenarios where you need to build a SOAP API to interact with some legacy systems or something, but really REST is going to be the modern default. Now let's talk about the flip of this. So a REST API, the client makes a request. With a webhook, the server actually announces something. So this is really popular with integrations. So if you want to be notified when something happens, oftentimes services will provide webhooks that you can hook up to so that you receive a notification when something happens. So that's pretty much the summary of webhooks. Definitely important if you're building any kind of notifications.
Yeah, so if you're building a payment system, then webhooks are very good because as soon as the payment is completed, you'll get a notification that okay, this transaction happened, and then you can. So that's why, like, there are two ways you would have seen that page which says that do not refresh after you complete a payment. So there are two ways to implement that. One is to all in every 2 or 3 seconds ask the server, has the payment been done? Has the payment been done? Or you can just let the server tell you in, let's say, 1 minute that, okay, the payment was done or it was not done, and you get your answer. So that's where you use webhooks to for the second option where you get the notification from the payment provider that, okay, the payment was done or not done. So yeah.
Systems or interacting with other services out there on the internet. Now let's talk about GraphQL. This will serve a similar purpose to something like a REST API, but the way it's done is different. The idea here is you can make a request to the server. Let's say you were trying to retrieve some information, but you can adjust that request almost like a structured query language query, SQL, with it instead being called GraphQL. So the client can adjust that request and retrieve just the information it needs. The cool thing here is that on the back end, you just set up the GraphQL endpoint, set up some rules or restrictions, but then the client has control and can request exactly what it needs. The control is put into the client's hand, relieving some effort on the back end. So pretty cool structure, especially if you do enjoy like the database feel of it, where you can select exactly what you need to retrieve from the the appropriate requests. So you can set this up in your application so that the clients can go in and adjust their requests with like a web page, and it's not always in code. So pretty cool thing that you should probably at least know the basics of. Next up, we have a couple of things here that say RPC.
Yeah, so the good thing about GraphQL becomes that it minimizes the data that comes from the backend, but it also maximizes the data that is being sent from the front end. So it has its own pros and cons. I don't prefer GraphQL that much. It's just better to talk to your develop backend team and figure out the minimal amount of data that is needed.
which stands for remote procedure call, which you can think of that idea as invoking a function on another computer. JSON RPC is a very simple implementation of a communication protocol, but a major difference is that it's bidirectional. So REST is a one-way thing where the client makes a request and then the server responds, but the server is never going to initiate the communication. With JSON RPC, you can have bidirectional communication where the server initializes some communication. This is handy for real-time communication because the server can say something as soon as it needs to instead of waiting for a client to make a request. gRPC is a very similar idea, and this is a protocol built by Google, and it's going to utilize protobufs, which is one of the other notations we're going to talk about. So protobufs are really useful for inter-app communication. So if you have microservices, or perhaps you are working with some lower level languages and you want to integrate that with an API you built in another language, you might communicate between these apps using protobufs. So gRPC is a communication protocol that utilizes protobufs, and it's a bidirectional protocol, so the server can communicate to the client directly without waiting for a request. WebRTC, server-side events, and WebSockets are all things for real-time app development, so you can look up all of the differences about these. I would say that WebRTC's specialty is with things like video. Server-side events is when servers need to broadcast events, and then WebSockets are ideal if you want ongoing instant communication. So if you had a video game or instant messaging, that's probably where I would go with WebSockets. So when it comes to getting a grip on all of these, REST is the default for APIs. Learn that. When it comes to real-time stuff, learn WebSockets. When it comes to broadcasting announcements, webhooks. When it comes to inter-app communication, gRPC or REST. So that gives you a pretty good idea of these different comms protocols. Now I've said protocols, but really you should probably consider these as means of communication or architectures for communication using protocols. So HTTP, HTTPS is a really good example of a protocol that REST uses to communicate over. So the protocol is actually more of the technical spec detailing how that communication actually happens, and all of the communication styles we just talked about are made possible thanks to the protocols. So perhaps this would be better just said as APIs or communications, where HTTPS, Hypertext Transfer Protocol, and Hypertext Transfer Protocol Secure, these are probably the two most popular, is a layer lower. So HTTP and HTTPS will use TCP, so this gets all into the different levels of networking. It's not going to hurt. TCP is used to make network connections. Another one you'll probably hear is UDP, with the primary difference that UDP is not a reliable means of communication. You can think of it as one computer broadcasting a message, and then anybody who picks up that message takes the message, but if they don't, is a connection-based protocol. UDP is connectionless. If you need to transfer data and you need to make sure it gets there without being destroyed, that's where TCP is going to come in. Now, as a developer building APIs, you don't actually usually have to worry about this, but if you start working with lower level systems where there's some network communication, then you might have to be aware of messages being transferred via TCP or UDP. Now, another thing I want to mention is that devices get IP addresses. You'll see IP 0.0.1. That's an example of an IPv4 address. That's the loopback IPs are given to the entrance to your network, and then devices within that network can have IP addresses that are local to that network. Meaning my device on my network might have the same IP address as your device on your network, but because those IP addresses are just local to our individual networks, those are not a conflict by any means. However, we should both be given a public IP address from our internet service provider. These will need to be unique, but that public IP address is for my entire network and does not uniquely identify a single device. Due to there being a limited number of IPv4 addresses, IPv6 is being introduced and is slowly growing adoption, where you can now have many more different IP addresses. So that's IPv4 and IPv6. Next up, another protocol you should be familiar with is SSH. This is used to remotely connect to another computer. Often it's used to connect to a server, and the SSH stands for secure shell. And it's probably one of the first things you're going to get experience with when you start working with another server, where you're not just working on your local environment for building test applications. If you have a dedicated server and you need to work on that server, you'll connect via SSH. You'll be within the terminal, so you'll probably want to be comfortable with a terminal-based editor if you need to edit any text files, for example. So we'll get into some of that as well, but that is a pretty important protocol to be familiar kept on the server, whereas IMAP will have them downloaded so you can read them locally, but they're still up on the server. Then we have down here messaging. Wanted to add this in here, especially if you're working with something like RabbitMQ. Messaging software can be used to facilitate communication between microservices, so you don't always have to utilize just these things here. Software exists to help facilitate communication between smaller services, and these are the protocols that might be used behind the scenes. I think the major difference is this one being for more complex data, MQTT for simple data, and STOMP for simple text-based data. So those are something you might at least want to be familiar of those words, and you can research them more if you are in a situation where you might need to use them. Now again, these are the protocols, so you're probably not going to be writing MQTT stuff. You're going to be utilizing something that uses these protocols. So at this point, we have a pretty good understanding of
So RabbitMQ is on pops up, Google Apps pops up.
different protocols you might hear about, as well as the different paradigms of communication. Now let's talk about the notation, which is when you receive a message, how do you actually parse the text to know what it says? So these are the main ones you're going to APIs, so you probably aren't going to be using that a whole lot for that. but they'll often be used together. A protobuf is interesting because of a few different reasons. The first is that they are serialized into a binary format. This takes up less space and makes communication more efficient. The other major benefit is that they have type information, so the fields within a protobuf will adhere to particular data types. The structure for the data is described in a .proto file. You can use the proto files to generate types, so for example, classes or structs in various programming languages. So if I build a bunch of information and I want to communicate to a new app with protobufs, I can give you the proto definitions and you can generate the correct types for your app, even if it's in a different language. So that is an overview of protobufs, or protocol buffers for the full words. Now let's talk about YAML and TOML. You'll probably run into these for configuration files. For example, a README file is going to be a .md file. Working with Markdown will allow you to easily describe how that information should be displayed, and there are a lot of Markdown renderers to show that information. CSV, or comma separated value, is a comma and import that into a different program. The ones I would probably start off with is JSON and probably Markdown, so you can create a README for your project. You only really have to worry about these others if you're using them for specific use cases. So if you're not working with protocol buffers, you don't have to worry about learning protobufs right now. I have core sections of this mind map. The next two sections, we have the app dev lifecycle, which basically talks about the most common things you're going to run, some of the most important cloud services. So we'll expand this and we'll go through these one at a time. So first, taking a look at your local device, or Unix or Mac. Now, within Linux and Unix, we could get into tons of different operating systems. Deploying to a Linux operating system, you might want to be familiar at least with some of the main Unix-based, but it's going to give you a much different experience deploying to Linux servers. So you should probably start familiarizing yourself with the Linux commands. As for local development, we have editors. There's so Vim, NeoVim, VS Code. IDEs, some examples would be PyCharm or Visual Studio. Abilities or features, thing built in the .NET world. So C#, you're going to get a lot of capabilities there. Which editors, you should probably try out everything. But you'll probably gravitate towards one, depending on version control. The biggest one here is Git. You may hear of Subversion or other source control systems, but if you want to host is the software. GitHub is a hosting provider where you touch yet. So we have Docker. This is pretty much the only containerization software you need to be familiar with. And then this is going to be used to create images. Now, this is something we could get into in a lot of detail. We're just going to go pretty high level here. Basically, you can think of Docker kind of like a very light VM that runs your code in isolation. And when you work with Docker, there are images and then there are containers. Images is basically a snapshot of what the container should look like, and you can generate containers from that. So when you create an image, you can keep that locally or you can upload it somewhere. Here are some of the most popular image hosting websites, which some of these are acronyms, which hopefully I can remember. We have Harbor. This one we have Google Container Registry or Google Artifact version, or ecosystem you're working with. So if you're hosting your source code on multiple different images and get them all working together, and because of that, we have this orchestration section with the most basic example here being Docker Compose, which is kind of like the often within whatever ecosystem you're working with. So if you're hosting your source code on GitLab, you might use GitLab's container registry. So that is the basics of Docker, but it's often the case you'll need to create containers from multiple different images and get them all working together. And because of that, we have this orchestration section with the most basic example here being Docker Compose, which is kind of like the default way of doing this. If you're working with Docker, you'll probably learn about Docker Compose, and this will help you run your applications. If you need a little bit more, there is Docker Swarm and Kubernetes. And then I have this one on here, Nomad, something I'm not actually really familiar with, but I read about that. So you might want to look into that in more detail. The big one you're probably going to hear about is Kubernetes. Some people will use Docker Swarm, but I would say in general, the preference has grown to be Kubernetes. And this will allow you to control your containers and basically orchestrate them, which is the entire section we're talking about. Kubernetes is going to help you deploy a bunch of containers, scale as needed, fix things if certain containers go bad. So it's additional software that you might end up using. There are a lot of different Kubernetes services out there, so I listed some of the popular ones here. Google Kubernetes Engine, Elastic Kubernetes Service, Linode Kubernetes Engine, Azure Kubernetes Service. I probably should have spelled these out. And then IBM Kubernetes Service, DigitalOcean Kubernetes. You can see there are a lot of hosts. Azure Kubernetes Service. I probably should have spelled these out. And then IBM Kubernetes Service, DigitalOcean Kubernetes. You can see there are a lot of hosted Kubernetes service. I probably should have spelled these out.
Okay, so let's say containerization is just making a VM out of, let's say, in very simple terms, making a VM out of your application. But orchestration you can see as uh, uh, depending on the load, making sure that enough number of VMs are open, all the VMs are getting some amount of load or equal amount of load, and all that comes into orchestration.
and then IBM Kubernetes Service, DigitalOcean Kubernetes. You can see there are a lot of hosts or basically allow Kubernetes to work nicely within a larger ecosystem. So this introduces some of the enterprise extensions. So a big one here being OpenShift from Red Hat, a couple of other ones you may have heard of here, which you can do additional research on. But the idea of enterprise extensions is that it's basically Kubernetes with more features and more cost. But that can sometimes be worth it, as these providers will help you deploy and get things working. So that is a crash course of containerization. Probably something we could have covered in a lot more detail, but this will give you basically the essentials. The next thing is you can start using CI/CD, continuous integration, continuous deployment, and this will help you deploy things automatically. CI/CD is a series of steps. You may also hear it known as a pipeline, and these steps will take your code from a repository such as GitHub, run any tests, any kind of validation, checking the syntax, and then ultimately deploy it onto a server. Now that server could be for a testing environment, or it could be your production environment. This could be tied based off of which branch you're deploying to, or various other configurations. So not only is it just taking the source code and getting it onto the production server, there are various other things you can do. A lot of testing is done in this stage to make sure your code meets certain expectations. So we're specifically talking about automated testing, where that could tie into a CI/CD pipeline. You could also first deploy to a testing environment, which can then be manually tested by developers, stakeholders, testers, anybody who would need to interact with the application before moving it to a production environment. So opening CI/CD, you'll see a bunch of different tools you can use. Jenkins is a very popular one, as well as GitHub Actions, GitLab CI/CD if you're working within the GitLab ecosystem, and Circle CI. Now there's also AWS Code Pipeline, Azure DevOps, and GCP DevOps. These are the major CI/CD tools for the big cloud providers. Each one of these is going to have its own way of doing things and potentially different limitations, so you might need to do some research on if there's a dedicated DevOps team. This is probably where they're working, and probably more in the containerization space. Now,
Jenkins is the most popular.
you can tie these two things together. So if they're deploying software, is test the software. I don't do any of that because I don't really make software that has bugs. But in theory, since you guys probably do make bugs, you'll probably want to test your software. Here are some of the most popular testing tools. Now, generally,
even if you don't make bugs, because someone else working with your software will not understand everything you have done and might break something.
There's probably a testing framework for whatever language you are using. I use PyTest here as an example. So if you're working with a particular language for your backend, find if you make some changes, you can run all your tests, confirm that they work, and this is a great way to check edge cases. So if you, for example, put the highest value or one above the highest value, what happens, what should happen? What happens if you make a certain request type to the API? You should get this type of response, making those things all automated. Postman is a great tool for those API tests, where I would probably use whatever language's testing framework for testing functions, so actually checking the functionality. Postman tests, I would instead check the end-to-end, so describing what the request should look like once, making sure your backend is fully functional, only your code, but you have to change the test as well. You also might have to debug tests, so not only can you have broken code, code to maintain.
All these should come into, like, Postman and Swagger should come into documentation.
That's what it's like to be a developer. So keep your tests minimal, just testing the core essential things you need to test, so you don't just have a will allow you to see all the endpoints for your API, but you can easily look through the different API possibilities and test them in the browser. Here's an example of what that might be in the automation tool tie into CI/CD, so you can automate some of that testing and making sure things work before doing an automatic visit to check that your website's working properly, which can help you confirm. It's probably the one of these three I would start with, and there are a bunch of other API testing tools out there as well. So whatever testing, for me, I just use all of that into a file so I can that you could use one of their cloud options of stuff somewhere. Thought I would mention some of these as you probably run into them. I don't think you really need to go GitHub issues development process if you want to try them. Companies do have a tendency to stuff, but that's an issues that the end users are experiencing. I'm not going to get into each one of these. The one I'm familiar with most is CloudWatch, which is part of AWS. So that will allow you to get an immediate view of your application, as well as keep track to make sure no issues are happening. With that, you might want to tie into some notification system, which some of these might have things for that built in, but two popular ones that I wanted to mention here is PagerDuty and then OpsGenie. So these are things that can text you, call you, say, hey, I know it's Friday night and you're hanging out with friends, but you just broke the entire website, so go fix that. So if that sounds fun, check out one of these. Also why you shouldn't deploy on a Friday, by the way. But that's pretty much the end-to-end. So let's do a quick review. Start with your local will testing as well to make sure things are going as planned. Big three cloud providers talking about the most common services. These services you should be familiar with. More stuff in data. What kinds? Yes, eventually having the understanding of other cloud providers is good to some degree, but even just knowing if you're going to be working in an Azure environment, go ahead and learn all of the Azure most. Microsoft, Amazon, go ahead and pick your favorite. Unfortunately though, you do not get unlimited free computation with Amazon Prime. Now when I was first learning these, I have to kind of memorize them. This frustrated me at first, but as I started to learn them, it was actually helpful because the Google Cloud Platform and Azure names are more general or generic that they're actually harder to remember. For example, AWS Elastic Beanstalk, such a specific, weird name that once you actually have it memorized, it's hard to forget. Compare that to Azure App Service. It's just kind of general. At first, that might be helpful because you can kind of get for what it is. Let's just start going through these one at a time. And I'm sure as soon as I finish this video, I'll think of a few going on with your applications. Then we have GCP Cloud Monitoring and Azure Monitor. Managed databases, AWS RDS, GCP Cloud SQL, or SQL. RDS is not the database, it's just the name for the database hosting. You need to store files for file update some from AWS has. In serverless, it still has serverless functions. The IAM or Azure AD Active Directory. The IAM is Identity and Access Management. So this is used to GCP Cloud DNS, and Azure VND, we have AWS. So say you wanted GCP Cloud Build or Deploy, and then Azure DevOps Pipeline. To containers, container rule different than serverless registry, but you might see the pre. But if you have normally level Kubernetes, we have AWS, but this is short for infrastructure as code. Something you might run into, you might not need to do it, but basically this gives you a way to describe the cloud infrastructure flexibility to control files. So when you make a request to a server, going back to this example here, you might have multiple servers. There's a few major benefits here. It will distribute and balance the load across multiple servers so you can scale, and it will allow you to replace individual servers. What are you going to do? One, handle more users, and this is fabulous, but that doesn't give you balance them, and just you're most likely going to want to have that fault tolerance provided by a load balancer. So you'll definitely want to scale out to some degree, and then you can adjust those servers vertically. The basics. You want to have good machines that can handle the workload, but you also want that fault tolerance, and you achieve. And then for other services, TBD. Also, I have mentorship if you want basically guidance, accountability, and skill sharpening to get to the point of being a good backend engineer and getting employed. I help people with that, so I'll have a link down to that below. So that's the first thing, the links. The second thing is check out the upcoming video. That's going to take all of this information and tell you the exact things to study. If you're new or overwhelmed with all of the different options, you don't have to learn all of these things to be in a
Cool, cool. Let's